Okay, guys, I just want to talk a little bit about graphics and then show you how to implement some graphics in SPSS. So generally, if you have a lot of data, you've probably heard the phrase, a picture is worth 1,000 words. So quite often, just being able to summarize your data parsimoniously is one way of kind of getting your message across. And I've got a nice quote here. This is from, somebody who's kind of quite famous in the visualization field. It's graphical excellence is that gives the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space. Basically, when people do visualizations, there's always a temptation to make it too complicated. The Excel graphing we did at the beginning of the semester, rather than do a simple 2D graph, do a 3D graph with lots of, added bells and whistles and labels, etc. And sometimes those visualizations aren't particularly effective. So let's just show you two graphs. So this is from a psychology experiment. We've basically got three different types of therapy and two outcome variables. And we're showing it in a 3D graph because we've kind of got two X's and one Y's. Now, it's very hard to work out. I know we've got kind of confidence intervals for each of the variables. These are these kind of flat lines here. So it's very hard, to work out which are the highest. So is this one the highest or is that one the highest? I'm not entirely sure. It's quite hard to see with like the 3D perspective. A much simpler way of actually doing this graph is we have the two measurements, the thoughts and actions, and we have the three therapies, and we just plot it like as a clustered bar graph in 2 dimensions. And we can easily see here now, for the thoughts, BT is higher than no treatment, and we can get a much better idea of the relative level than we could with the 3D graph. So here's another interesting one. This is going back a long way. I'm not trying to be politically biased in any way, but this is kind of from the 2012 presidential election, the Republican primary, and you were supposed to say, your kind of approval of a candidate. So you might approve more than one. You might approve of more than one candidate. So 63% of people approved of Huckabee, 70% Palin, and 60% Romney. The problem is pie charts are designed as proportions that everything should add up to 1 or 100%. And here, this graph makes absolutely no sense because rather than being the proportions of a pie where we're splitting up 100%, the graph total adds up to nearly 200%. So here's another bad one from the UK. This is like we're trying to celebrate the NHS is 50. That's the National Health, the Health Service in Britain. The 65th birthday, and you're asked a question: how would you like to celebrate this? And there's basically too many parts of the pie chart. The 3D just confuses a little bit. The cake actually hides some useful information in the size of the segments. And overall, you know, it's just a little bit too complicated and a little bit of a mess. Similar to this pie chart here, we have the origins of food consumed in the UK. Obviously, a lot of that comes from the UK, 50%. And again, there's too many countries here. We did have another category, but in reality, here we can't see, what's the difference between China, Colombia, and Turkey. The graph's too small. Ideally, we want to set um, the threshold for other to be much, much higher. So maybe we'll have the UK in the next 5 or 6 countries and then the remaining countries another, because this is just a little bit confusing. And again, this is another Excel one. It's like, oh, we've got some 3D charts in Excel. We've got 4 different products and we're trying to find the profit per part over time. And again, a 3D graph is not really helping here. Another example here, we've got another 3D graph. We've got 2 X's, and this is just a toy graph. We have 5 people, 5 directions, and then we try and plot the graph. But a lot of the information here is actually hidden. We can't see, for example, this green at the back, and we can't see the 5th green number. So again, 3D graphs sometimes actually hide rather than hinder the information you want to show. So just thinking a little bit about scale, we've got 2 graphs here and showing an increase in house prices over 2 years, between 1988 and 1999. So the first one, it looks like the house prices have increased a huge amount. But in fact, relatively, they've not increased very much. In the second one, we actually show, from a base of 0, and we can see that they haven't actually increased very much. Now, which is correct here? In the first graph, the kind of the ratio, the aspect ratio is all off. It almost looks like the house prices are 3 times as much in 99 as they are in 98. But at the same time, in the second graph, um, you know, you really can't see very much of the increase in detail. Here you can actually see, if you're reading the graph properly, there is this increase of $2,000. You could not read $2,000 from that second graph. So in reality, there's no real right answer there. It depends very much on your application, but you just need to make sure that the reader understands what is being shown. So the first one you might want to label, relative increase in house prices. Sometimes you'd have like a little line going backwards and forwards like a Z, and that kind of just shows you're not going from the base, just to show people that it's not actually the base. This was actually kind of quite interesting because this is both types of graph um, on the same. This is a political leaflet and showing that employment is up. And again, want to show a big increase of employment is up. So we're using like a base of 28. We're using the non-zero base here. So we've got, again, the skewed aspect ratio. Okay, no idea what I did there. So we got the skewed aspect ratio. And the second one, we actually want to show that the deficit is down. And here, we've reduced the deficit by nearly a third. So we actually have quite a big drop regardless without putting a non-zero base. So they've actually used a non-zero base here. So this is like, again, not being politically biased, but this is a political party trying to show the numbers in the best context possible.